Hi, in this given section we are going to talk about maximum flow problem, so let's get started. Basically the first question is that what is this maximum flow and what is this flow network? Basically we have a graph with vertices and directed edges, as we have seen for graph traversal algorithms and shortest path algorithms. So we have this G graph with the V vertices and E edges. And it's very important that in a flow network we have two very important vertices or nodes, basically a source and a sink. We represent the source with an S, and basically the flow is coming from the source. So if you are familiar with higher mathematics or physics, in these cases the divergence is greater than zero. So the flow is coming out from this S source. And we have a T sink, we represent it with a T, and the flow is heading for that given sink. So the divergence is smaller than zero. Okay, and if you want to have a good grasp on flow networks, then you can imagine it as a flow of water in pipes, for example, or flow of cars in the traffic, where the edges are the streets or the roads. Okay, it is the same basically. And for example, the vertices in these cases are the crossroads. Okay. There are two important features and properties for a flow network. We assign a capacity to every single edge. That's basically the maximum flow to that given edge, or a pipe or a road, whatever. It's very important that this capacity is just an upper bound for the flow. And the second parameter is basically the flow value. We assign it to every single edge as well. So basically we are going to assign two features and two values to a given edge, a flow and a capacity. Basically the flow is the actual flow, so for example 10 gallons of water per second or 3 cars per second or so on. So this is the flow. Basically it's going to determine that what can we flow through that given pipeline or road or street or whatsoever. And the capacity is basically the upper bound for the flow. So the flow cannot be greater than capacity. Okay. So let's consider this graph. As we have discussed earlier, we have two important vertices in that given flow network, the S source and the T sink. Okay, and as you can see, the edges are coming from the source because the source has a positive divergence. And the edges are going in the direction of the sink because the divergence of the sink is smaller than zero. So the flow is coming from the source and it's heading for the sink. Okay, and basically it is a normal graph with vertices or nodes and directed edges. And as we have discussed earlier, we assigned two parameters, two values to every single edge, basically flow and the capacity. The first one is the flow. Okay, at the beginning we initialize all the flow values to be 0, so that's why all the values are set to be 0, but basically the first parameter is the flow. What is the flow? For example, 10 gallons of water and so on. So the actual flow on that given edge. And the second parameter is the capacity. What does it mean? That this edge, for example, is capable to flow 10 units. For example, it can be 10 cars per second or 10 gallons of water per second or whatsoever. As you can see, the capacity of this edge is greater than the capacity of this edge. Basically, it is able to flow twice as much water, for example, as this edge. And this edge is capable of flowing 3 times more water than this edge. So the capacity is basically the capacity we have been considering in physics when we are discussing, for example, electric currents and so on. So we have the capacity as the upper bound of a flow. So in this case the flow is 0, it means that no water is flowing in this given edge. The maximum value of flow for this given edge is equal to 10. Why? because the capacity is equal to 10 and the capacity is the upper bound of the flow. So when the flow is 10, it means that we flow as much water in this given direction with the help of this given edge as possible. We are not able to do any better. We are not able to flow, for example, 11 units when the capacity is equal to 10. We are able to flow 10 units. Okay. And you may pose the question that what's the aim of this maximum flow problem? Given a flow network, this G with the V vertices and E edges, and just find a flow with maximum value from source to sink. So this is the source, this is the T sink, and we have to find the flow parameters that's going to be the maximum. Okay, so you may pose the question that, okay, but why is it good? And we have come to the conclusion when we were discussing shortest path problem that we are able to reduce lots of other problems to this shortest path problem. For example, when we were discussing the Forex related problems, how to find arbitrage situation. Or for example, how to get rid of lines and strings of pixels if we want to shrink an image in Photoshop or GIMP. It has nothing to do with shortest path algorithms, but we have managed to reduce this problem to a shortest path algorithm because we know how to solve a shortest path algorithm problem in polynomial time. And basically it is the same for here, that lots of problems can be transformed into a maximum flow problem, and we know how to deal with maximum flow optimization. Okay, so this is why we like these flow networks and maximum flow problems. Thanks for watching.